So we're going to do some division with alternate methods, and including the standard algorithm. And there are other ways to do division. We used concrete materials last time, using the base 10 blocks. And we can use also pictures, and then we'll go to more abstract methods after that. So today's class is about division algorithms. Specifically, we're going to do an open array. Then we'll move to repeated subtraction. Then we'll do the standard algorithm. Then we'll do the explicit trade method. And then we're going to take a look at 1/7, or estimating. We'll do estimation. And then we're going to take a look at 1/7. We haven't done sevenths really. So we'll take a look at that. So our first division algorithm method is the open array. Now the open array method is similar to the open box. So when we did open box method and area models in multiplication, you can do an analogous method using an open array or open box with division, okay? So we take our example and 762 divided by 3. And so we draw a box. I'm going to start drawing a box and put 3 on one dimension. So we're using the area model. One dimension is 3. We don't know the other one. We don't know how long it is, but we do know the total. And the total is 762, but when we put 762 like this in a box, then it's kind of hard to figure out what the other dimension is. So what we're going to do is we're going to do what they call number chunking, where we'll separate 762 into nice numbers, nice round numbers that we can easily divide by 3 to get to this up here, that dimension. 762 can be done into, let's see. How about if we take off 600? Because 600 is a nice number I can divide 3 by. 3 times what is 600? Well, it's 200. Okay. And when I do I'm going to do a little bit of subtraction to keep track of what I have left. So 762 divided by 600 is 162 left now. I'm going to break 162 into another chunk that's easily divisible by 3. Maybe 150. Okay, and that would be 3 times 50 for that one. So I'm extending my box now. I got 12 left. That's a nice number that's divisible by 3. And it's 4. Okay, so I've built up my horizontal dimension by chunking up apart the area, the total area, into number parts. Okay. And the distributive property says that I can do 3 times 200 plus 50 plus 4 and get the same total. Therefore, 762 divided by 3 is equal to 254. So let's do another example of that one, that open box method or open array. You do 237 divided by 5. So we set our 5 as one dimension of a box, and we kind of leave it open until we finish chunking up 237, and then we can close it and find the actual array. Let's have a volunteer just kind of voice a number. What number should we use for our first chunk of 237 to divide out by 5?
200.
200. Okay, so I'm going to keep track of the 200 here. So if the area in the middle is 200, one dimension is 5, then what's the other dimension? What number should I write here?
40.
40. Okay, great. Now I have 37 left. Now, what number should I chunk off of 37 that's easily a multiple of 5?
$35.
Good, 35. Oops. Okay, so 37 minus 35. I have 2 left over. That one's going to be 7, and then we'll put a 2 here.
14.
All right, so what do I do now? What do you guys think? That's not divisible by 5. How do we handle the remainders that aren't divisible by the divisor?
You
What
can
could we
make
do?
them a fraction.
Yeah, let's do a fraction. So you have 2 left over. The group size is 5, so your fraction is 2/5. Therefore, 237 divided by 5 is equal to 47 2/5. Okay. The next one that we're going to do is called repeated subtraction. And some of you that may work in schools might have also called this something else. I first learned of it as called scaffolding. Some people call it the Big 7 method. Okay. So it's a little bit like what we've been doing with where we're going to chunk up our total or our dividend into pieces that are nice to divide. And because you can do that, this algorithm can go pretty quickly compared to the standard algorithm. The standard algorithm takes out or divides out the most efficient numbers, or the most you can divide out of each place by place value. And in the open array and the repeated subtraction method, we don't worry about place value so much. We just keep repeating and chunking the numbers and dividing off. And then we can add up the number of groups. So for our first example, we have 504 divided by 4. So the repeated subtraction method is set up like the standard algorithm up until this point where they can then draw a line down. So I'm going to draw the frame here that we usually see with the long standard division algorithm. The line down is going to separate our groups from our total. Okay, so separate the divisor from the dividend, the quotient from the dividend, sorry. Divisor's out front. Okay. So this part right here is room for our quotient and partial sums. This right here is where our dividend goes, or the total. Now 504 was our total. All right, so what's another nice large group of 4 that we can just start taking out? What's a multiple of 4 that's not bigger than 500, but a nice big number? Just subtract it off. We'll keep track of the groups on the outside. It's kind of like what we were doing before with that chunking. We're going to break off a big chunk of 5 from the 504.
400.
100. Oh.
Yeah, good job. 400. If I subtract off 400, I'm going to record the number of groups that is on this side, and that was 100. So you have 100 4s in 400. And if I take away that chunk, I'm making the problem a lot easier to divide out. Okay, what's a big chunk that I can take out of 104 that is a multiple of 4?
100.
Now you can take off another 100. Take off 100, I mean. You have 4 left over. That was 25 groups of 4 right here. I'm going to add these together. I'll put the 25 a little bit more in the lining the columns. And what do I need to do left? I have 4 that I need to divide by 4. How many times is 4 going to 4? Well, once. Put 1 time there. Subtracting 4 gets 0 as my remainder, so I don't have to take off any more groups. I'm going to add these right here so I can know how many total groups were taken off. I get 126. Therefore, 504 divided by 4 is equal to 126. Okay, so you got the repeated subtraction method. There, let's do another example. I'll have you guys go guide on that one as well. We want to do 162 divided by 6 with repeated subtraction.
Sorry, forgot my antibiotics.
And so we go 6 going into 162.
I don't want to go. I'm scared. I'm scared. I hate the game.
All right, so what big chunk can I do from 6 with 6 from 162?
120.
At 120 comes to mind. Okay, so oops, I forgot to do the big 7 part. I'm going to subtract off 120, which is how many groups of 6? How many groups of 6 was that? I'm recording those on the outside.
20.
Okay, good. 20 groups of 6. So that's a nice big chunk. I have 42 now. We all know that 6 times 7 is 42. So there's 7 more 6 groups of 6 there. And that becomes 0, which means I'm finished. I'm going to add up my groups to 27. Therefore, 162 divided by 6 is equal to 27. Okay, repeated subtraction method. All right. We have our standard algorithm next.
Did go on a plane.
To use standard algorithm, we want to think about place value. And this is similar to what I ended with last time, but many of you had to go. And it's actually, this is where we treat it. Using base 10 blocks as a guide, as we break up hundreds, tens, and ones, we're going to describe each of the steps in the standard algorithm using handwritten descriptions. Focusing on place value, focusing on concepts. So we're going to do the 762 divided by 3 again, okay, with the standard algorithm. So we set it up like this, where there's 3. And I'm going to go, and so this one you need a little bit of room on top, so that was a little bit too close to my grease line. So let's go 3 into 762. All right. Now when we consider 762 objects, we have 7 hundreds, 6 tens, and 2 ones, right? Like in our mind, we can visualize the base 10 blocks. When I'm going to take those and I'm going to put them into 3 groups, okay? What I have my 700s. Okay? So the first step, okay, we're going to take the 700s and we're going to put 200s into each group, right? So let's go ahead and think about the first part. Okay, so there's our first steps, right? We think about 3 going into 7, or taking 700 and dividing it into 3 groups. You can do 2 into each group, but there's some leftover. Okay, so we're going to think about just the 2 at first here. From 700s, in the 762, we're going to put 200s into each of the 3 groups. Okay. And so that's where the first 2 comes from. So we're going to draw an arrow here. That's why there's a 2 there. We've taken 200s from our 700s, put them in each group. So the standard algorithm takes each place, it takes out the maximum number of groups you can, and then looks at the rest. That's why you're going to subtract. Now, we're going to go ahead and subtract. I'm going to leave some space to talk about these other parts here. Let's go ahead and go to number 2 here. Okay, in number 2, the second thing we're going to do, consider is that 600s total were put into each group. I'm explaining this step right here. So 600s were put into each of the 3 groups overall. I'm going to state that. So overall, we've used 600s. So that's going to be this one right here. That's what that step means. Even though I'm writing 6, the place value is important. I'm actually considering 600s. Okay? So I'm just, the standard algorithm uses a little bit of shorthand when they do the division. And so I have 600s were put into 3 groups. Now, when you do that, we have 100 left over. On step number 3, 100 was left. Now what we're going to do with that is we're going to break up the 100 into 10 tens. And then we put them with the 6 tens. Okay, thinking place value, you can imagine this is place value blocks. Putting them with the 6 tens from the 762. Now when you do that, you have 16 tens total. Okay. All right, step number 4, and oh yeah, so let me catch up on my numbers. 16, that's the bringing down part. Bringing down of 16 is when you're just, or bringing down the 6 is you're just adding the 6 tens to the 10 tens that you just formed there. So there's that part. Now in step number 4, I'm gonna put that right here, because then we're considering the 16 tens from the 16 tens, we put 5 tens into each of the 3 groups. So when we think about how many times 3 goes into 16, it goes 5 times. Okay? What you're doing actually is you have these 16 tens, and you're taking 5 of them and putting them into each group. Okay? All right, so that's what this part means. And that's why I'm kind of grouping these up here and point them to the quotient there. So when we've put 5 into each group, we haven't used all of our 16 tens yet. We've only used 15 of them. That's what we're going to note down here, because that's what the 3 times the 5 is. And we make a note that 1 10 was left. Okay, and we're going to break up the 10. So when we're describing what it means to bring down this 2. So we can break up the 10, because now we consider that number as 12, right? Instead of just 1, 10 left over. So we'll break up into 10 ones. And put with the 2 ones. From the 762 for 12 ones total. That's what we're going to do here now. We have 12 ones total to distribute among the 3 groups. Okay. So that's what step number 6 is here. So we have our 12 ones. We need to distribute them from 12 ones. Put 4 ones into each of the 3 groups. When we do that, we get the 12 here. Subtract that off and we get nothing left. Okay. And that's step number 6. We are only thinking like, or noting that there was no remainder. Sometimes there is, and so we'll put something there.
Wouldn't that be step 7?
Yeah, thank you. Okay, and then I'm skipping Let's see. I need to note that there was 12 ones were used in this here. Yeah, so I skipped another little bit here. Sorry about that. We'll move this down. No, let's just go back. I think you guys are following just fine. So let me, I don't need to be all that explicit. Okay. Okay, so that's kind of like how you do the standard algorithm with attenuating a place value, describing what happens. So what we're going to do in the next part here is we've got another example of this type of exercise, and we're going to have, I'm going to have you guys describe, just chime in about what to do for each one. We're going to do 732 divided by 8, okay, with the standard algorithm. So I'm going to put my 8, oops, 8 and 732. So 8 is going into 732. 732 is divided by 8. And so what's the first thing that we will notice when we do the standard algorithm?
That 8 can't go into 7.
Right, standard algorithm takes place by place and divides them into the number of groups that there are. So there's 700s, and we can't take 700s and put them into 8 groups evenly. Okay? So what do we do? And maybe you can use base blocks in your mind as a way to know what to do. What do we do?
We break up the 700s into tens.
Good. So there aren't enough hundreds. Okay, and so you want to explain this if you're explaining the algorithm here. There aren't enough hundreds in 732 to put 1 in each group. Okay. So then we break up, okay, using base 10 blocks as an imaginary model, you're going to break up those 700s. We break up the 700s. Oops. Okay, we're breaking up the 700s into 70 tens. And put with the 3 tens from the 732. And when you do that, you have 73 tens total. Okay. Now we're going to consider the 73 tens in step number 2. From the 73 tens, what are we going to do? And so now we have this to consider, all of these together. We can put those into 8 groups, there's enough. But what are we going to do? What are we going to do exactly, I guess?
Put 9 tens into each of the 8 groups.
Right. Remember, division algorithm is going to take the most it can from each place. So now we have 73 tens, put most of them, as most as I can, into the groups. And why did you choose 9?
Because 8 times 9 is 72.
Right, so you're going to use almost all of the tens, right? So you can put 9 tens into each of the 8 groups. And that's what we're doing right here. Once we do that, we have this that we've done. And that there. So 72 tens are put into were put into the 8 groups. Okay. We have 110 left. Once we found that 110 left, what do we do next in the algorithm?
Break it up into 10 ones because you don't have enough to split it into 8 groups.
Right. Always check, because if this number here, if this number is bigger than this one, then that means you have another group you can take out of 8. If it was like 9 or 10 or something. Right? So check that. Because you don't, you have to break that up into smaller places. We have 110 left, we're going to break that up into 10 ones. And put it with the 2 ones from the 732. Okay, for 12 ones total. So that's what we mean when we say we're bringing down the 2. That's like the description of what's going on with my symbols and my placing there. What we need to do is we need to focus on place value so that the students know what that means. Okay? So I'm taking my 10 breaking up into 10 ones and putting it with 2 ones. So I have 12 ones total. Okay, so I have 12 ones from the 12 ones. We're gonna put 1 into each of the 8 groups. And so that's what I'm considering here. I'm considering 8 into 12, okay? So there's, when I do that, I say, okay, 12 ones, I'm gonna put 1 into each of the 8 groups. Okay. And then number 6 here, I'm gonna describe this line, that 8. 8 ones were used. 8 ones were put in, 8 ones were put into the groups. That's how much I used from my total. Okay. We notice that the remainder is 4. We have 4 that we can put into different groups. So 4 ones were divided. We're going to divide them among the 8 groups. For 1/2 in each group. Okay, and that's where we're going to put that right there. Okay, so 4/8 is the same as 1/2. Draw a line from here. To there. Okay, so there's our next example of how to describe the standard algorithm using place value language and notation, continuing to those parts. Any questions so far? Okay, something you guys have seen your whole life, but described very detailed, probably more than you guys want to know or care to know. But it's fun stuff, it's good. Okay, so in summary, we have 732 divided by 8 is equal to 91.5. Okay, the next one here is explicit trade method. It's like the standard algorithm, but we're going to put each of the quantities that we're considering into a column. Okay? So we're going to do, our example is 889 divided by 7. 889 divided by 7. And the explicit trade method sets up just like the standard algorithm. So we do like 7 going into 889. Sometimes it's helpful to do this when you write the standard algorithm, 889 divided by 7. Okay? Instead of saying like goes into, you can do it more accurately that way. That way the students know which number is going inside the frame. Oh yeah, and with this explicit trade method, I'm gonna need some room. So I'm gonna, for between each of these 3 digits here, so I'm gonna extend my digits spacing to about like that. So there's 2 digits I can fit in below each one. Okay. Now you consider the same process. We're going to go ahead and draw columns to keep our places. Draw column lines just right after the number in your dividend. 7 goes into 8, or 8 can be 800s can be broken up into seven groups by putting 1 in each group. And so then now I have 100 left over that wasn't used. The breaking up into tens, like we did in the standard algorithm description, is shown in this method by using an arrow and writing a 10 under the 8. Okay. So I'm going to draw my arrow in blue because they get kind of running together. Okay, there's the 10, and what we're going to do is we're going to put that 100 broken up into 10 tens, put that with the 8 tens. And when you say put that with the 8 tens, we're going to actually sum it inside this frame to get 18. Now we're just considering 7 going into 18, or 18 divided by 7. We know that 7 goes in there 2 times. Oops. Subtract our 14 from the 18, just like normal, and we have 4 left over. Now this 4 is going to go up into, it's 4 tens right now, but we're going to consider it as 4 ones, and we break up the tens into ones. We're going to add that to the 9 ones that are already there. So we're going to put that all the way up here. Add them together and you get 13. Okay. So we have 13 ones to consider. No, hold on, that was not right. The 4 tens becomes 40. So we want to put 40 here. Okay, so our 4 tens becomes 41s. That's what I said, but I wrote 4 on accident and left a 0. All right, now we're going to add them together. We get 49. That's what we're considering, to 49 ones to break up into 7 groups. And it happens to go in evenly. Then we have our 0 left over. Okay, so this is the explicit trade. You can imagine doing this with base 10 blocks. So just some different ideas that people have had to divide numbers that we're showcasing today. So we're going to do 389 divided by 4 with the explicit trade method. So I've set up my frame like this, long division frame with some lines coming down. Okay, what's my first step when I do long division? Okay, you guys are gonna guide this one more than me just talking, so let me know what to do. When I do long division, what do I do?
Look at the first place value.
Right. Do I have enough hundreds to place into 4 groups?
No.
No. So what we do is we break up that 3 hundreds into 30 tens, right? And with the explicit trade, we are going to add that. So we're going to break it up like this and put an arrow just from the first column to the second column where my 30 is. And when I break those up into 30 tens, I put that with the 8 tens from 389. And I have 38 tens now to distribute among 4 groups. Now what's the number of groups that we're going to do? how many groups of 4 are there in 38?
9.
9. Good. Let's put our 9 up here. And we're going to 9 times 4 is 36. So we've distributed 36 total groups of 10, 36 tens. And so I have 2 tens left over. And that 2, what am I going to do with that 2 with this method?
Break it up into 21s.
Good. Break up into 21s. I'm going to put the 21s right here with my 9, add them together for 29 ones. Okay, so I'm going to put my arrow up to this way. That 2 becomes 21s. Now I have 29 ones to distribute among 4 groups. How many are going to be in each group?
7.
7. Oops. Right. It's 4 times 7 is 28. So I have a remainder of 1. And you just put that with the 1/4 here. Okay. Oops. Let's try this one here. I forgot to say, therefore, 889 divided by 7 is equal to 127. Okay. So from the one that we just did, oops, we know that 389 divided by 4 is equal to 97 1/4. Okay. Any questions on explicit trade? Okay, so those are some ideas that you can do with your students to demonstrate division. What we're thinking about now is some estimation ideas. Just for a couple minutes. Let's divide. Let's estimate that. When you estimate, what are you kind of doing? Saying you're going to approximate, right? How big that number will be when you divide. How many groups of 8 are in 1,344? What's helpful that we were doing before was the chunking idea, or just kind of thinking about like big numbers that go around 1,344. So if we do 8 times 200, okay, that's a big number right there, 1,600. We do 8 times 200, we get 1,600. And that's too big. So the answer to this is not quite 200. Okay, this is the number that we're looking for. So let's go down a little bit.
Could it be like 150?
Right. So if we go down a little bit by 8 times 100, we get 800, which is too small. Okay, so this one right here is too big. So we know that our answer is between 100 and 200. And so one suggestion was 8 times 150. We know our answer is between 100 and 200. And so we kind of can draw an arrow and say maybe about 150. Okay. So those are the things that you do with estimation, is because division can be thought of finding a missing factor in a multiplication problem. And so here I was trying to find the missing factor when I multiply 8 times something to get close to 1344. Okay. That's how you can use estimation. What do we do? Yeah. Here's this here. Another example. You can estimate 1/7 as a decimal. What would 1/7 be as a decimal, do you guys think? And why? You can use some nice benchmark fractions around 1/7 to help you.
1/6 is 0.6 repeated.
Excellent.
Isn't 1/8 0.125?
Okay, good. Let's go ahead and formalize our thoughts here. 1/7, you guys have great thoughts. So 1/7 is between 1/6 and 1/8, right? We know that it's closer to which one of these two numbers?
1/6.
Right. No, actually, it's closer to 1/8. Because on a number line, you have 0, 1, a half, and there is a fourth, and there is an eighth. Okay. Notice that as my denominator is increasing in size, it's getting closer and closer to 0, but by smaller amounts, or by the smaller amounts are here. Okay. And we're going to compare 1/6 and 1/8. So 1/6 is like a third of half. There's 1/6. So it's going to be closer to 1/8 than 1/6. So notice that the distances are getting smaller, smaller and smaller, but the rate that they're getting smaller and smaller goes down, and so that means that it's going to be closer to 1/8. So 1/7 is between 1/6 and 1/8, closer to 1/8. So we're going to go, okay, 1/6 is equal to 0.16 repeating. 1/8 is equal to 0.125. But it's somewhere between there. Maybe it's about 0.1 something for sure, right? Because it's not bigger than 1/6. What number could I put next? What digit could I estimate it could be?
Four.
Like a 4, right? Okay. There may be more digits. Great. Now, at the end of the homework for this section, there's an investigation on 1/7. And we can start it here in class for the last 10 minutes. Okay, so I still need to take attendance, so I'm going to say, all right, I want you guys to find out what the decimal approximation is by using the standard algorithm. That's 1 divided by 7, so it's 1 divided by 7. Okay? So go ahead and work on that. Just keep dividing until you can come up with something to say meaningful about the decimal, what it would be. Okay? So go ahead and do that as on your notebook papers as I take attendance. Okay, 7 going into 1, or 1 divided by 7. Okay, so we have 7 minutes. Let's go ahead and kind of move on here. What did you guys get when you're dividing this?
0.1428 repeating.
So we got 1 was the first thing, and that's 1 times 7 is 7. Subtract off 7, we get 3. After 1, what did you say to do?
You would add another 0.
Yeah, with decimal division, we haven't talked about this explicitly yet, but keep adding zeros, and you can do that because they don't add value to the number. So I'm not changing the value of the number, just the form, so I can go ahead and keep doing more division.
And that's 4. And then it's 2. And then it's 8. And then you're going to get 6. Or,
How
oh,
about
no.
4? Bring down the 0 for 40.
That's 5.
5. How many of you guys like 1/7 as a decimal so far? Pretty cool, huh? 10 minus 5 is 5. Bring down the 0. Another, and then a 7 for 49. 1. Okay, did anybody get this far? 1, 2, 1, 4, 2, 8, 5, 7.
Yeah, and then wouldn't it be, since we're back at 10, it would just do the same thing over again?
Yes, it would. How cool is that? It'd be a 1, 3, no 0, 4, and so on. This part right here will repeat. So we put a bar over this whole thing here because it will go again through that cycle. 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. You can do 1 divided by 7 on your calculator and it'll show fun things. This is called the repetend of the decimal, the part that repeats, okay? Repetend. Okay, the repetend of 1/7 is 1, 2, 3, 4, 5, 6 digits long. Okay. So from our investigation of the estimation of 1/7, we got 0.14, so that was good. No investigation. But what they want you to do, okay, yeah, so in summary, 1/7 is equal to 0.142857. And that repeats. Okay. So in the homework, they want you to kind of take a look at 1/7. Actually, they want you to take a look at all of the sevens. These are the rest of the sevens. So you have 1/7 here, and then 2, 3, 4, 5, 6, 7s. So we have like 3 minutes. So let's use our calculator. Does anybody have a calculator handy that they could just help us calculate these? Maybe you can use your phone.
I do.
Okay, Nicole, you got 2 7s. A volunteer for 3 7s.
I can do 3 7s, Dr. B.
Okay. Next one, 4 7s. Just divide it. Okay, great. Thanks, Shelby. Divide it on your calculator and tell me what the answer is. 5 7s, volunteer. Tony, did you volunteer for one? Five 7s. Tracy, can you do 5 7s?
I can do it.
Okay, great. Let's have another person for 6 7s. Mo, Tony, Marley, anybody? 6 7s.
Dr. B, for 3 7s, I got 0.428571429.
Okay. Next person, shout out what you got.
I have 2 7s.
Okay.
And it's 0.285714 repeating.
Okay. You mean like this?
Yes.
Okay, great. 4 7s. Who had 4 7s?
I did.
Okay.
It's 0.57
Mhm.
142857 repeating.
Okay. Great. And 5 7s.
I have 0.714285 repeating. It was 4-2.
Yeah, I missed it too. I was like, something wasn't right here.
Yeah, you're good.
Thank you. 2. What was after 2 again?
8, 5.
Okay. Yeah, because the repetend for all 7s is 6 digits long. Okay. Did anybody by chance get 6 7s here?
Yeah, I
I
got this.
did.
Okay. What we're going to do is actually we're going to deduce what 6 7s is. So thank you for those who are trying. Let's go back to 2 7s. We got that one. 3 7s has to have a repetend. What would be the numbers that repeat? Because I only got a portion of the decimal. So I'm thinking 4285714 because, or 41.
It's 4-2.
9 part. Go ahead. Sorry, what were you saying?
Yeah, the 429 part. Sorry. So you're right, Dr. B.
Yeah, no, you're right. But I just was translating what your calculator readout said to what it actually is, because we know that it repeats every 6 digits. The 429 is the beginning here, and the calculator rounded this digit to the 9 because this one right here is a 5.
Mm-hmm.
Okay. All right, so we're gonna go ahead and erase those. For the next one, we're going to do 5, 7, 1, 4, 2, 8 because we're going to repeat the 5, 7 thing again. Okay, so we erase those. All right. Now let's look for a pattern and deduce what 6 sevenths will be.
Would 6 sevenths start with an 8?
Oh, actually, yeah, which would it start with? I don't know if we could do this out from the pattern.
Well, because the pattern is, it looks like it goes 1, 2, and then it skips 3, it goes 4, 5, and then it skips 6, and then it goes 7. So then
Okay.
8.
Why would you say 8 and not 9?
Because it goes 2 numbers consecutive, skip a number, and then 4, 5 is the consecutive. And then you skip 6. So then you need 2 before you can skip again.
Okay. If the 8, now those people who have calculated this, thank you for doing that. And we can check it. Now, if the first number is 8 because of your pattern, okay, the consecutive numbers, so notice the consecutive numbers here, and they skip 1. Notice the consecutive numbers here, 1 and 2, skip 1. Okay, and then 7 and 8. What would be the next number? Using the pattern of previous sevenths calculations, we can deduce what the next number will be. And this is the biggest part of the pattern. And if you guys do need to go, that's fine. This is the last thing. Anybody could stick around and help me with the pattern.
Are you referring to 7 sevenths and then it would be 0 because it goes 7, 8, and then skip 9 and then go back to 0?
Not quite, because I'm going to actually look at what this number is. What's the next digit in 6 sevenths?
Is it 1, 4, 2, 8, 5, 7?
Now, how did you get that?
Because in the pattern it goes 1, 4, for 1 seventh it's 1, 4, 2, 8, 5, 7, and then it starts, and then it's 2, 8, 5, 7, 1, 4, and then if you would skip or keep going, it would be 2, 8, 5, 7, and then it goes 4, 2, 8, 5, 7, 1, and then it would be 4, 2, 8, 5, 7. So it's just the numbers rotate. That's really what happens.
Right. Does everybody understand what she just described? Notice that in every seventh, they always use the same digits in the same sequence, but they're shifted. Okay. 1 7 here is 1 4 2 8 5 7. 2 sevenths, 2 8 5 1 4. Okay. The 4, the 1 and the 4 are now, for 2 sevenths, the 1 and the 4 have been shifted to the back. Okay. So they have the 2 8 5 7 and then the 1 and the 4. Notice that in the from 2 sevenths to 3 sevenths, they've also been shifted. The 4 and the 2. So the 2 was shifted to here, and the 4 from the back was shifted to the front. Notice that 8 5 7 1 is still the same. In 4 sevenths, we have this from the 3 sevenths to the 4 sevenths, we have
The 5, 7, 1.
5 7 1 was moved to the front. Okay, and the 4 2 8 was also kept in that sequence. Okay, so look at, there's like some cool shifting going on. Okay, and then from 4 sevenths to 5 sevenths, the 5 went to the back here, and all of these are the same. Now, for those people who did 6 sevenths, was our guess right on that one, or did we need to do a little bit more shifting differently?
That was right.
Yeah. So, yeah, so the 8 5 was moved to the front, and the 7 1 4 2 was shifted down the back. Okay, so that they wanted you to kind of do this little exploration for the homework. But anyway, that's all we have for today, and thanks for sticking around for a few more minutes. I hope that you guys have a wonderful day. Let me know if you have any questions.
Thank you. Have a good day.
Thank you.
You're welcome. So Kenna and Aspen, do you guys have questions? Okay, I'll go ahead and end our meeting. Let me know if you have any by email.